In this video, I'm going to do these three questions from the chapter Trigonometry class 10. Let's begin with the first question here. Now, in the first question, we have to prove that sine theta multiplied by 1 plus tan plus cos theta multiplied by 1 plus cot is equal to sec theta plus cosec theta. Now, in a question where you have all trigonometric ratio, like we have sine, we have tan, we have cos, we have cot, as well as sec and cosec involved. So clearly we'll be writing all trigonometric ratios in terms of sine and cos. So let's begin with the LHS. In the LHS, what you can see, I can say sine theta is this only. I can write tan as what? Sine over cos. So this is sine theta over cos theta. Plus then we have a cos theta, say this is cos theta only, that multiplied by 1 plus cot, and cot is what? Cos theta over sine theta. Now next we are going to take LCM over here, say sine theta is as it is. If I take LCM over here, it's going to be what? Cos theta. So 1 multiplied by cos theta is what? Cos theta. So this is cos theta plus sine theta. On the other side, we have cos only, and LCM is what? Sine theta. So we'll keep sine theta, and this is 1 multiplied by sine theta is sine theta plus cos theta. Now what you have to check here that this is cos plus sine is common, right? As you can see. And this is a very important thing to understand, that whenever you are solving any trigonometric ratios or identities, you have to keep in mind that simplification is what we look for. And whenever anything comes common within the numerator or denominator, you should take out common. So sine plus cos is cos plus sine, as you know, addition is commutative. So if I take out sine plus cos common, what we are left here? We are left with sine theta over cos theta. And on the other side, we have, not on the other side, the next term as cos theta over sine theta. That's what we will get after simplifying this. And then we will be taking LCM over here. Let's say I take LCM now. So this is sine theta plus cos theta. And if I take LCM inside this, the LCM is clearly sine theta into cos theta. Maybe cos into sine, and sine into cos is same. So sine multiplied by sine is what? Sine square theta, and cos multiplied by cos is cos square theta. So what do we get here? As you know, sine square theta plus cos square theta is 1. So we are getting 1 for this. One more time. What I mean to say that sine square plus cos square theta is 1. So replacing this with 1, what we are left with? We can say we'll be left with sine theta plus cos theta, that divided by sine into cos. Sine theta into cos theta. Now check what we are going to do. We are going to do next is to split this. If I write sine theta, that divided by sine theta into cos sine theta into cos theta, right? Cos theta plus, then we have cos theta, that divided by sine theta into cos theta. So you can figure out from here that this sine and sine get cancelled, this cos and cos get cancelled. So we are left with 1 over cos plus 1 over sine. Now this is a trick which you should keep in mind, that after every one step, you must give one glance to the RHS. So our steps should be guided. Our steps should be guided by what we have to prove. Now you can figure out that 1 over cos is what? Sec theta. So this is secant theta, and 1 over sine is what? Cosecant. So this is what is equal to RHS. Now let's begin with start the next question. Now in the second question, it says if sec theta is equal to x plus 1 over 4x, we have to find sec theta plus tan theta. So clearly we have the secant theta, and then we have to get the tan theta. So we know that tan theta, like tan square theta is what? Sec square theta minus 1. So let's say this is tan square theta only. I can replace secant theta with this value. That means it's going to be x plus 1 over 4x the whole square minus 1. Now how to simplify it further? For that I'm going to do expansion. Well, there are other methods. So I'll write a square plus what is the b square? That is square of this, which is 1 over 16x square plus 2 times a multiplied by b. So what you can figure out, and then minus 1. Now let's take this one. I'm talking about the after reducing what we are getting. So let's write it again. This is tan square theta is equal to, we have x square plus 1 over 16 times x square and plus half minus 1. Now you have to figure out that this is what we have obtained. This is what we have obtained from the expansion of this, right? This is what you have to keep in mind, because the next step is what I'm going to apply this as. This is tan square. Now on simplifying this, what is half minus 1 is what? Minus half. So I can say this will come as what? X square plus 1 over 16 x square, and half minus 1 is minus half. Now let's figure out once again. If the expansion of this gives you this, that means a square plus 2ab and plus half, right? Then then on factorizing this, what we should get is an important thing. So let's understand once again. So we have LHS as tan square theta. So can I say the on the expansion of this, if I am getting this, so for plus half, and in case of minus half, it should give you what? It should give you the same term. Instead of plus over here, it should be minus, right? So one more time, this is a square plus b square, and this is minus 2ab. And that's why I wrote like this. Now for the rest part, what we know that this is tan theta. There is a square, right? So it should be what? Plus minus. The value of this is going to be x minus 1 over 4x. Now we have to get the value of secant theta plus tan theta. We have the value of secant theta, and for tan theta we have two possible values. So now taking the positive values first, if I ask you what is tan theta, secant theta plus tan theta. So if I get secant theta plus tan theta, taking positive value of this, first I'll replace secant theta with x plus 1 over 4x plus this, right? Because there is a, I have taken the plus first. It's going to be x minus 1 over 4x. You can check that here. This and this get cancelled. It results to give you 2x. But as I said, we have two possible values. In the next go, I'll find once again sec theta plus tan theta. And the value of sec theta remains same. This is what the value of sec theta. So the sec theta is x plus 1 over 4x. And this time I'm going to take the tan theta as negative of this. As I said, we have two possible values of tans, plus of this and minus of this. So minus of this will give you what? Minus x and plus 1 over 4x. So here we can see that minus x plus x get cancelled. 1 by 4 plus 1 by 4 is half, right? So 1 over 2x. Now you have to remember that we have two possible answers for this. One is 1 over 2x and other is 2x. These are the two answers for this particular question. Let's go to the next. In this part, that is the third part, we are given x is equal to p secant theta and y is equal to q tan theta, and we have to check as an MCQ which of them are the correct relation. So what we know that we have a relation between secant and tan theta, right? Secant square theta minus tan square theta is equal to 1. So I'm going to apply this. Let's extract secant theta from here. So what is going to be secant theta as? This is secant theta will come as x over p, and tan theta from here should come as y. What? Y over q. Now check, we have to get secant square minus tan square. So if I plug in these values over here, right, it's going to be secant square, which is x square over p square. This is x square over p square minus tan square is what? Y square over q square is equal to 1. So what in case if I take LCM, this is x square. I should write down the LCM plus first. This is p square q square as the LCM. So x square multiplied by this is x square q square minus y square p square is equal to 1. Now next I'm going to transpose this p square. So what it results to give you? It should give you x square q square minus y square p square is equal to 1 multiplied by this is what? P square q square. So if I go for the options over here, I can see that this is what? X square q square minus y square p square is equal to p square q square. Yeah, that's how this question can be done.